Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on rate conversion. This was requested by Hussein Shabazz, so thank you very much for requesting, and if you want to request your own video, make sure to leave a comment. This particular Khan Academy assignment is actually really important. A lot of future subject areas, even outside of math, like chemistry, will need this type of math. So let's go ahead and get started. Raya is applying mulch to her garden. She applies it at a rate of 250,000 centimeters cubed of mulch for every meter squared of garden space. At what rate is Raya applying mulch in meters cubed over meters squared? All right, so a couple principles we need to understand here. First, we need to know how many centimeters are in 1 meter, okay? And it's 100, okay? There's 100 centimeters. Centi means 100, so there's 100 centimeters in 1 meter. This is kind of important because this is our building block of meters squared and so forth. So if we're talking about 1 meter squared now, essentially what needs to happen is it's not just 100 centimeters squared for 1 meter squared. Now we're multiplying 100 times 100. Okay, so that's actually, we're going to put 4 zeros. So it's 1 with 4 zeros. 1, 2, 3, 4. So it's 10,000 centimeters squared per 1 meter squared. Okay. And then for meters cubed, okay, so if we have 1 meter cubed, then we're going to be taking 100 centimeters, and we're multiplying it 3 times, okay, as indicated by the 3. So I'm multiplying it 3 times. And I'm going to be using this, I wouldn't want to call it a trick, but this like simplification later on, because we just count the zeros here. So 1, 2, 3, 4, 5, 6. So do 1 with 6 zeros. 1, 2, 3, 4, 5, 6. That's centimeters cubed in 1 meter cubed. Okay, that's important. That's going to help us do this whole process. Okay, and one way I do this quickly is I just look here at, there's 2 zeros in centimeters to meter. And if I know that I'm going to go to 3, I'm just going to triple that. So then I have 6 zeros instead of 2 zeros. So it's kind of like the shortcut, I'll call it, to do some of these conversions a little bit more quickly. All right, so the first thing I'm going to do is I'm going to state the current conversion or the current units that we have. So I'm always going to write that first. So I have 250,000. I'm just going to keep that number out in front. Then I'm going to put my units to the side, okay? And I'll put it multiplication. Units go to the side. This is the current state, okay? So I'm changing it to meters cubed. So if I want meters cubed to be in the top, I'm going to put it in the top, okay? So I want meters cubed in the top, so I'm going to put it in the top. I want meters squared in the bottom. It's already in the bottom, so I don't really need to do anything, okay? But I can't just convert it to meters cubed. I have to have, I have to have a proper conversion rate, before I do that. Okay, so if I have meters cubed here, if I were to multiply these out, I would have centimeters cubed and meters cubed. Essentially what we're doing here is we're trying to cancel out all the units that we don't want anymore. So what does that mean for me? Is I'm going to put this over my conversion. We just did that. Okay, we have a relationship between cubic centimeters now and cubic meters. And I'm trying to cancel away the cubic centimeters and only be left with my cubic meters. So I need a conversion. We already did that. I'm going to go ahead and put it in, let's make it, I'm going to keep it green actually. So I know there's per 1, let me write the number here, per 1 meter cubed, there are 1 million centimeters cubed. Okay, let me extend this a little bit more. Okay. That's all I have. That's all I need, okay? So let's see what this does. First off, let's just consider crossing off the units. The whole goal of this is to cancel off units. As we know in like real basic multiplication of fractions, if we have something like this, 2 times 5 over 3 times 5, if we see something on the top and bottom, we can cross it off, and the answer would be 2/3. Okay, 10 over 15 would be reduced to just 2/3, and we can cancel off that common factor. It's the same thing with units. So if we have centimeters cubed and centimeters cubed, we're going to cross off just the units, not the numbers, just the units. Okay. We don't have another cubic meters in the bottom, so we're just going to leave that. And the same thing with meters squared. There's nothing in the top. And those stay, and we want them to stay because that's our end goal. All right. So now that I have cubic centimeters crossed off, now I can go about the business of doing the numbers and seeing if we can cancel off anything in the numbers. So if we have two numbers with lots of zeros, we can cancel a zero for every zero. This 250,000 is in the top. This 1 million is in the bottom. So every zero can cancel off with another zero that we have here. So every zero that I have in the top can cancel with the bottom. So I should have 4 crossed off in both. Once I'm done with that, I'm going to rewrite this because it's kind of messy. I have 25. Let me do it in blue. Oops. Trying to get my blue here. All right. So I have 25, okay, times, I crossed off centimeters squared, so that's gone. I'm going to put just 1 meter squared times meters cubed. I'm not going to put the 1 in front of it, over 100. So now I'm almost done here. If I want, I can always put this number out in front over 1 so you can see clearly what's the top and bottom. And we're just going to multiply across. So I have 25 meters cubed for every 100 meters squared. And that's my answer. Now, I should simplify this though. So anytime you're dividing by 100 or multiple of 10, what we can do is we can just take the original number, 25, and we can move the decimal over that many times. And if you're confused on this, I have other videos where I talk about how to divide by 100, etc., that you can look up. But I'm going to assume that you know how to do this. So again, there's 2 zeros, 1, 2. So I'm going to go 1, 2 here, and that is 0.25 meters cubed for every meter squared. Okay, so that's it. It seemed like a very difficult process, but once you get going, it's really not that bad. So 0.25 is my answer here. Check it, and we'll move on. All right, here we go. The batting wing Zi Ying uses to fill quilts has a thermal conductivity rate of 0.03 watts per meter per degree Celsius. What is the batting's thermal conductivity value in watts over centimeters times Celsius? Okay, a lot going on here. So let's go ahead, let's go ahead and write down what we know. 0.03 watts per 1 meter times Celsius. Okay, so the only difference here is it has this centimeters instead of meters. Okay, so we're going to go ahead and just put the units that we want. We want watts in the top, that's already there. We want C in the bottom, that's already there. But now we have centimeters in the bottom that we want, so let's go ahead and put centimeters in the bottom. I'm going to give myself a little space. Okay, problem is you can't just put centimeters in the bottom because you have to get rid of the meters. Okay, we don't want meters anymore, so we're going to put meters in the top also to cancel out. Okay, when you do that, you have to have a proper conversion. So this needs to be a conversion right here. So I need to know for every 1 meter, how many centimeters do I have? Luckily, it's not like centimeters squared or anything. So I'm just going to put like 100 centimeters for every 1 meter. And it doesn't matter. There's 1 meter for every 100 centimeters, but there's also 100 centimeters for every 1 meter. So don't get caught up in like, does it need to be the top or bottom? The only thing you're worried about is we need to cancel the units we don't want, in this case meters, and we want our unit conversion of the units that we do want in the correct location. So we have 0.03 W over 100 cm times C. We should do some simplifying here. Okay, luckily this decimal is getting worse, not better. We're dividing by 100, so that means we're going to move the decimal over 2 times. 1, 2. You're going to fill in a 0 for every empty space that we have. So really what we have here, arrow, is 0.0003 watts for every centimeter Celsius per degree Celsius. Okay, so I'm going to just type in 0.0003. So 3 zeros before that 3. Should be good. All right, here we go. Next one. These are actually all easy ones. There's not double conversions. I'm hoping it gives us a double conversion at the end because I really want to show you one of those ones. But for now, they're giving us kind of easy ones. Boulan rows on a crew team. Her team rows their boat at a split rate of 2 minutes for every 500 meters. Okay, so we want to do meters per minute. So this one's actually the easiest. Is we're just going to flip it. It wants meters on top, right? So we're going to flip it 500 meters over 2 minutes. And I can just flip it because the units are the same. We have meters here, minutes there, minutes there. There's nothing being converted, actually. So we're just going to flip it. The next thing we're going to do is we're just going to divide it. So 500 divided by 2, that gives us 250 meters per minute. So this is actually a useful thing because if you're doing like track splits or trying to improve your time, you'll often have to do this to figure out how fast you're actually running. So 250 meters per minute is our time. Whoops. And hopefully it gives us a good one at the end. And it doesn't. A certain food has a gluten ratio of 13 milligrams of gluten per liter of the food. Okay, actually, it is giving us a double one. So this is a good one to end on. What is the gluten ratio in micrograms per milliliter? Okay, so I'm not sure how many micrograms are in a milligram. Okay, so it gives us milligrams. Mg is milligrams. I'm guessing it's one down, but I'm going to have to look this one up, I'm going to be honest. But let's start with just writing down what we have. So we currently have 13 mg over 1 liter. Okay, so that's our current one. What do we want to end up with? We want to end up with micrograms per milliliter. Okay, so we went from a larger unit to a smaller unit, and a large unit to a smaller unit, okay? So we're going to see what this does in just a second. I need to look up, though, the amount of micrograms to milligrams, because I don't know that one. Okay, so here's what I know. I know that, and because I want micrograms on top, I'm going to put micrograms on top. 1 microgram, okay, is equivalent to 0.001 milligram. Okay, so you can also do the other way around. You could have, let's see, 1, 2, 3. You could have 1 milligram is equal to 1, 2, 3, 1,000. Whoops, I did this wrong. This is supposed to be micrograms like this. There we go. It looks exactly the same, but all right, so I could do 1 microgram per 0.001 milligrams, or I could do 1,000 micrograms for every 1 milligram. And I'll actually go that one. I think most people probably like that one better with non-decimals. So I'm going to go ahead and put that one down. And again, I want micrograms on top to end up on top, so I'm going to put milligrams here. So let me do that in green. I have 1 milligram. I'm multiplying everything. 1 milligram on the bottom. 1,000. We'll make it like this. Micrograms in the top. Okay. So that's 1. So that's that's just the milligram conversion. Now I need the milliliters. So I want milliliters to end up in the bottom. So I'm going to have to put liters on the top. 1 liter for every 1,000 milliliters. Milli means 1,000, so I knew that one. Wasn't sure micro. Okay. So now this is all good. And the reason why it's all good is if you look here, when we're going to be canceling, we're going to be canceling milligrams with milligrams, and we're going to be left with micrograms in the top. That's what we want. We're going to be canceling liters with liters, and we're going to be left with milliliters in the bottom. Okay, so just wanted to clear that up. Let me rewrite this. I'm going to rewrite it in purple, actually. Okay, so I'm going to rewrite this in purple. There we go. So I have 13 in front, over 1. I can put it over 1, that's fine. that got canceled, times 1,000. Okay, that's what I was referring to when I said that got canceled. Okay, no milligrams in the bottom anymore, but I have micrograms here. I'll put this over 1. The 1's still there. Times, liters got canceled. I can just put a 1 over 1,000 milliliters. And you'll notice that I have the correct units that I want. I have micrograms and milliliters. So now it's just a matter of canceling out the numbers, the coefficients. Okay, so that's 1,000 and 1,000 cancel away. We're left with 13. And we have 13 times 1 is just 1. Or sorry, 13 times 1 is just 13 over 1 milliliter. So it's 13 micrograms per 1 milliliter. Okay, so it stays the same because it has the same unit of conversion. Okay, so because we converted this one and this one in comparable units, they're both 1,000 times smaller. It stays the same exact number. Okay, but I'm glad we saw this double one at the end because that's a little bit more tricky that you have to do it twice. So that's all there is to this video. I hope you enjoyed it. If you have any questions on it, please ask a question. This can get kind of complicated. Either way, if you need any more help, make sure to check this channel out next time right here. Wes Explains Best.